Welcome back to a new episode of Wild Voices, our podcast dedicated to understand better the animals and the wonder of nature. And today we have a very special guest, Andreas Fallmann from Global Diving Research. He's an independent scientist and you focus, welcome Andreas, you focus on the physiology of cetaceans and other marine mammals, and you go deep in better understanding how they organize the way they breathe and they go underwater. And many people are interested in that. So my first question will be, how come you decided to go in that field of research?
Because there's so many intelligent and smart people and no one is investigating the lungs, there's no competition.
That's a good answer. And then you discovered it was not such an easy topic, I guess.
No, I now know why no one is doing it. It's tricky. It's very interesting. The lungs are an amazing organ. It's one that we absolutely need. Most people that do it, or many people that have done physiology, have focused on the heart. And there's been some studies, very few, especially in cetaceans, on the lungs, partly because they are so extreme in what they're doing. And also it's difficult to do it. You need, in the olden days when you did physiology, you captured an animal and then you did some measurements. And now with the capacity of using animals in human care, with being able to communicate with them through the trainers and doing this on their, if they want to, on voluntary participation. So if the animals want to participate, they do it. For that reason, I think we have now reached a point where we can do some really, really interesting things. And hopefully, respiratory physiology could become more of, we use trained animals. We can do these things with the participation of the animals and then get their input on how they actually function.
It's funny the way you present it. It's like the animals themselves are participating actively to the research and helping us to understand how they cope with their environment. You used the word extreme. So you and I, we are mammals, we breathe air. We don't think about it most of the time. Extreme is the real world for marine mammals. Can you give us some insight of the capacity of these animals?
So if you make a comparison with how fast these animals can breathe and how they breathe, one, they breathe completely different from how we do. So we do an inhalation, exhalation, and then there's a really short pause for the next breath. A dolphin or sea lion take an exhalation, inhalation, and then there's a long pause. Seals breathe a little bit different. They breathe more or less like humans.
Okay.
But you have this long pause, especially in cetaceans, in between the breaths. The interesting thing is when you go swimming or when you're newly born, you breathe like a dolphin.
That's
so this seems like it's an in-water thing, and some people have suggested that this is due to buoyancy because you inflate the lungs and then you float better. It may have some impact on gas exchange too, because if the lungs are inflated, it seems like gases can flow in and out of the blood much easier. So you have better capacity to do that. So there may have some benefits, especially in the marine mammal lung that has the capacity of, think of a balloon and then the alveoli see each balloon. When they're diving, they can collapse, so they can completely close. In humans, we can't do that easily. Especially, it can collapse, but then we can't open them up, and this is a clinical issue. And understanding how these animals can collapse the alveoli, open the alveoli, may have implications for people in surgery and also for prematurely born babies. So some of the stuff we're doing have direct clinical implications.
Oh, that's very
But also understanding how these animals do this and why they breathe certain ways. One is a conservation issue. It's better we can improve our conservation impact if we understand this, and we'll probably talk about this some more. But also it has clinical implications because the tools that we now have built can help us identify respiratory disease, and this is both in human care and in the wild. Respiratory disease, especially in cetaceans, is one of the main causes for trauma and mortality. So if we can identify that early, in animals in human care, if we can identify that in different populations in the wild, if we can help stranding teams to identify if you have several animals on the beach, which animals potentially have respiratory disease, that may improve how many animals they can save and which one has the best chance of survival.
And you go directly to the next question I had is why you are here in Lolo Parque. You are doing some study with us, and you are happy to get access to the animals. So what did you do this morning, for example?
So one of the important things with these animals that we have here, we know their status, we know their health, we know where they come from, we know their background, and we can, with the interpretation of the trainers, get access to so they can help us understand things. So one of the things I'm interested in is better understand the lungs. So what tools can I build to measure how the lungs function? Okay. I can't run around. So basically what we do is it's like you go to the doctor and they do spirometry and they put a device in your mouth and you take a deep breath and you exhale, and then he says, oh no, you don't have asthma, but you have pneumonia.
Exactly.
Here's the medication, come back in 2 weeks and we're going to do the measurement again. So we can build tools that are similar to that. And then we can
built that yourself?
No, not me. There's people much smarter than me. I just get the opportunity to play with them, with the animals.
Yeah.
So we built this specifically for dolphins, but a dolphin is much smaller than a killer whale, and now we want to try to see, can we use this tool also in killer whales? So before we do big investment in making studies, applying for funding, building new tools, what do we need to do to be able to use this device to potentially study killer whales? So to come here and do some preliminary tests on these animals is really useful, because otherwise we would waste time, money, and animals' time and people's time, and it may not have worked. So now we come out here, we've done some preliminary tests, and it seems like with some small modifications we can actually build a tool that is portable, we can bring into the field, and then we can do some measurements on wild animals.
That's very interesting that this is this back and forth between the wild and the zoo, and so maybe you can tell a little bit more about it. You said already a lot, but having the data from the animals we know so well here with their cooperation help you to build tools that you can deploy in the wild as well. And for example, this kind of research can help animals in the wild?
Yeah, that's what we're trying to do. So let's go back to the dolphins, because that's what we worked on the most. But we can start doing similar things with killer whales or with other animals that are in human care. So with the dolphins, we have a data set that stretches 12 years. And with all those data, we have animals that we are certain they're healthy, and other animals that we know have some type of respiratory disease. Oftentimes it's pneumonia. So we can then follow the pneumonia when they contract it, and then the treatment. So we do measurements during that time. So we have all these data. Now we're using artificial intelligence to tell us these are the changes that happen during when an animal has disease and during the recovery process. So now we can use this tool. We do some measurements on an animal as a preventative measure. And then we can see which animals are healthy, and is there one animal that is potentially sick, then the veterinarian can do some follow-up.
Okay.
One of the problems with respiratory disease in cetaceans that probably a lot of your audience know is they hide the disease really well. So they don't show symptoms until they're really severely...
Yeah, wild animals tend to hide that they're not doing well, of course, because otherwise you're in trouble.
Otherwise you're in trouble in the wild. So now we have a tool, we can do preventative medicine, and we can do some measurements and then do this like you do with a doctor. You go to the doctor every year and you take a blood test, and it says you need to go back to the doctor, or no, you're fine. You need to lower your cholesterol. So
or divers do the testing once a year at least,
exactly.
And that's exactly the same.
Exactly.
Okay.
So for stranded animals in the wild, we can basically use this tool because they're stranded and they're not swimming away. So we can do, and we're working with some stranding networks in North America that are doing this. So we have about 2 years worth of data that is really interesting. We work with health assessments with wild animals where where we go out and
that's important.
and we check the health status. So there are veterinarians, there are people from zoological parks and biologists and physiologists that are doing measurements on these animals. So to be able to tell the health status of this population here, and this was actually really important in the lawsuit against BP for the Deepwater Horizon oil spill. BP said, no, it was not us. There's no problem with these animals. Yeah, a little bit of oil, but no, they're fine. And by having this baseline knowledge of the health of those animals in a control situation in a different population, they could say, no, this is what a normal population looks like.
And then you can measure the impact.
Exactly. Yeah. This is what your population that was exposed to the oil spill looks like. There is a huge impact on health on these animals.
And on the long term, I guess, the impact is running for years.
Yeah, exactly. So this project has been ongoing for 55 years now, since 1970. So they're trying to do health assessment with regular intervals, and it's really important to follow the animals. Where actually the lung function data we have, this seems like something happened after COVID.
Okay.
There is a huge change in the respiratory capacity in the dolphins in this area, and we don't know why.
Okay, so you're opening really a window on the health
so we
of
can
the animals
track this population through time and then see what happens. And there's also other studies ongoing. There's several different studies on so they take blood samples, they take fecal samples, they take sputum samples.
So they have the whole set.
The whole set. Yeah. Like you're going to the doctor and do, in some animals, in some years, they do an X-rays, they do an ultrasound. So we get a good view of the health of each individual. And then oftentimes they're released with suction cup devices that can then do measurements of the animals when they swim away.
You open an interesting topic now, the biologging. Biologging. You are very skilled in that. You have used biologging in your career. And what are we using now with marine mammals as biologgers? What can we do and can we measure on the animals?
It's advancing so rapidly.
Yes.
They're new satellites, so it's been an issue before. We haven't been able to send that much data to satellites so we can just release animals. So oftentimes they're different types. So you can attach an instrument and then let the animal go. It sends information to satellite, and then you can sit at home at your coffee table and receive the data. Or you need to work with animals and retrieve it, and there are different ways of doing that. So for penguins and for sea lions that come back and seals that come back to the same site, you can then retrieve it when they come back. The other one is you need to release it and then retrieve it. So then you need to have a way of finding it. And nowadays with GPS, this is becoming not easy, but easier. So you have a general location, and then you have what's called a radio beacon on it, it's on VHF, so then you can hone in on where it is, and then you have people with very good eyes, and they can see it in the ocean.
And you get all the information back.
Then you get all the information.
And what kind of information? You can record sounds, you can record location.
Yeah, you can record speed. Speed is tricky, but accelerations, you can get a very good trajectory how these animals move in the ocean. You can record sound, and there's especially one type that has been dominating that. They call it the D-tag. There are other ones that are coming out now. The problem is the range, the frequencies that they can measure, and the quality of the sound. Yeah. But it depends a little bit on what your research question is. But so you can do hydrophones, you can do magnetometry. Some are trying to do speed. There's one that they're trying to measure heat flux. So you put suction cup sensors on the skin of the animals, or you can put the sensors on sea lions, and then you can measure how much heat is emitted by the skin. And this has to do with thermoregulation and looking how do these animals manage when they're diving down to several hundred meters where it's 4 degrees or 8 degrees.
How they cope with the environment.
How do they cope with the changes? Because water is really draining of heat. So if you're in the ocean, even in the summer, and you stay in too long, you get cold. So how do these animals deal with that? And what impact does that have with climate change? because
that's another
maybe
big
it's
topic.
not the cold that is the issue, especially these large animals. Maybe it's the heat that is the problem. And we're looking at that. So I'm doing a project with a Danish colleague called Lars Beider with humpback whales in Hawaii. And one of the interests there is the mom and calves do long resting dives, where mom sits still, the young calf sits still, but he can't dive as long, so he comes back and forth. Why are they doing that? Is that to rest? Is that to maybe dump heat because it is quite warm there? Sometimes they're chased by males, and sometimes they may have to do this. And then what happens if the ocean is heating up and it becomes warmer? Will they have to do this more often, which may impact other behaviors that they need to do?
Yeah.
So trying to understand the physiology, I think, is really important in connection with behavior. So we need to have both. It's sort of yin and yang. If you only focus on the behavior, then I think you're missing a huge component of the physiology.
So all these data help you to build the picture, the global picture of how they cope with the environment, how they dive, how they are impacted by, you said, global warming, but other activities as well. And something that I find also very fascinating is that this ability they have to dive, it's not only physiology, it's also planning, it's also thinking.
Yeah.
Can you tell us a little bit more about that?
Well, so they need to go to the food store. The food store is 200 meters down the ocean, and they need to find the food, and then they need to go to the food. So we have a pretty easy time. We know the food store is around the block, and I can jump in the car and drive down there. But
easy for us.
Yeah. What about now if, because of climate change, it moves 15 blocks down? It's going to take me a longer time to get to the food store. I'm going to waste more time in gas. I'm going to waste more of my available time, which is going to cost me more money. I'm going to have less money available to buy food. So this is sort of the same thing as for these animals. They use oxygen to get it to and from the food source. So they need to plan that and if I can only stay down for this long, I need to find the food this quickly and then have this much food with me coming back up. So they need to balance that sheet, that I need to get enough food to outweigh the cost. And if I can't get that many pieces of food on one dive, maybe I have to do more dives, and that's going to impact the overall metabolic cost, which then leads to I have to dive even more.
They have to be efficient.
They have to be extremely efficient, and they do a lot of this planning. One of the things that we worked on, there's some indication that humans can do this too, but we know that a lot of marine mammals and also reptiles are able to manage their heart rate.
Yeah.
Not upwards. Upwards, I can just scream at you and you probably go up. But how do you lower your heart rate? There's some evidence in these Zen Buddhists and also gymnasts that they can probably lower their heart rate a couple of beats. These guys can do it in seconds. So they can go from 80 beats per minute to 40 beats per minute in like that. And they can manage this depending on the context. So we did a study where we had animals that were trained to dive on cue. There was either a short dive or a long dive, and they knew they had to do the short or long based on...
They knew in advance how long they had to stay.
Or it was one where, do whatever you want. You're going to hold your breath, you can do it for 20 seconds, you can do it for 2 minutes, do whatever you want. The responses were striking. When they knew that I'm going to do the dive for either a short dive or long dive, there was a little bit of difference depending on the length. The heart rate went straight down. When they did whatever they wanted, sometimes it went straight down, sometimes it sort of just ticked along and slowly decreased with time. It was strikingly different.
Yeah, so they can themselves planification, adaptation, and thinking.
So they plan that, and they also plan. There's some beautiful work by some researchers in California that has done this on sea lion, that they plan how much air they take in before they dive. So they look at, okay, I'm going to dive deeper because the food is deeper, so I need more air, so they inhale more. And vice versa if it's more shallow.
So they are not only athletes of the sea, they're also genius of the sea.
They're I think the more we discover, these animals have some capacities that you just wonder how they do it. There's some beautiful work by a colleague of mine in gray seals, and when we're holding our breath, for example, the cue to breathe is because of the carbon dioxide. So it's very uncomfortable after a period of time, and we need to breathe. And what breath hold diving humans sometimes do is they hyperventilate before they do. So what happens is you're basically removing a lot of carbon dioxide in your tissues and in your blood.
So you have more time.
Yes, you have more time before you feel this. Seals don't respond at all. They raise the carbon dioxide levels to that is extremely uncomfortable for a human, and they kept on diving. There was no response in heart rate. There was no response in the time that they were diving. They responded to oxygen, which they suggested they may have cues to sense oxygen. So they may be more responsive to oxygen. And they're continuing this work now. It's really interesting, this work. It seems to be, and we don't see the same thing. We haven't done the same studies, but we don't. The little work we've done, we don't see the same things in cetaceans, not in the dolphins. The dolphin seems to respond more like a normal terrestrial mammal.
Where they're coming from, like the seals and like others as well. There is also something that we see the incredible abilities of these animals. They can dive, and they have to find the food sometimes very deep. But at the same time, there is the feeling in the scientific community that we are challenging them sometimes a little bit too much with human activities going on around. We forget that when they have to go that way, they are pushing the limits of their body. And they also, you said, they plan to go they plan the dive. If something is going on in the environment that is quite shocking for them, or then they have to respond, and then the heartbeat can go up, and then there is a corpus of evidence showing that they can have decompression syndrome. They can if you disturb the dive, it's a huge problem for them. Can you explain a bit more? Because before, everybody thought that they wouldn't have to face that.
No, and this has been, so there's this research began with some researchers here in Canary Islands. So Antonio Fernandez in Las Palmas was one of the first that made these arguments that
we have to say it. I'm a new living man a French man in the Canary Island, but one of the most top expert scientists in the world on cetaceans. We have him in the Canary Islands in the university here. It's very famous.
So this was initially received by, no, this cannot happen. The same thing with turtles. So the people I collaborate and work with in Valencia, they discovered that turtles can do this too when they get caught in fish nets.
And they go up too quickly.
And they stay under for very long, and then they come up too fast, and they get these huge gas loads in their tissues and in their blood. And in some extreme cases, they die from it. So what are the differences that happen? So this has been a lot of studies. There's been a lot of studies, especially in cetaceans, looking at the behavioral responses and what are the changes when they're exposed to some of these stressful events. So it's Navy sonar, it can be killer whale calls, it can be maybe boats above. So what we're seeing is probably not just the behavior, and this is what I mentioned before. I think we need to get away from, they're responding in a certain way. Yeah, the response may be a behavioral response, but there's probably a physiological component
as well
connected to it. Because if you're not changing the physiology and they're diving normally, there isn't that much change, but animals get hurt. There's been strandings. So we do think that there is potential changes in, you scare an animal and heart rate comes up. So they have the decrease in heart rate when they're diving, and they do this to try to conserve the available oxygen. And then you startle them, and the heart rate comes up, and they waste some of that oxygen, and they start circulating more nitrogen, and they take that up into the tissues, and then they come back too fast. So there's probably both components may be important, and especially the physiological component. And this is another reason why it is extremely important to have access to these animals in human care, to be able to build the tools that it is not that easy to measure heart rate, which is an indicator of how much blood is circulating, especially in salt water.
Yeah.
And doing that on an animal that is free swimming in the ocean is a huge challenge. There's been some beautiful studies done that can do this now, and we've been trying to do this here at Lower Park with the killer whales to try to, what is the best combination of sensors? How do we attach this? Where on the body do we get the best measurements?
Signal, yeah.
It may be on the chest, but on the wild animals, we can never put it on the chest, at least not on a killer whale. Maybe on a dolphin that we can briefly capture, but on a killer whale, we just put it wherever we get, which is usually on the flank or on the back. But can we ever measure heart rate on that?
You need a control. Huh?
You need a control animal, and you need to repeat things over and over again. And this is why these animals are so extremely valuable, to be able to generate those tools that we can then bring into the wild.
And what I can add also is you made it very clear that when we disturb these animals when they dive, we can compromise their life.
Yeah.
They can die from that. And here we have a project with Olopark. We would like to prevent this to happen in all the islands in the Atlantic.
Yeah.
We call it the Macaronesian Sanctuary Project. And that's one of the measures we would like to promote at the European Parliament, to say that we should be very cautious about the way we use the sea, not to disturb their inhabitants.
Yeah.
And find a way to live together in a peaceful way.
No, absolutely.
And these data are very important to prove the point, to show that, okay, that's the way we should treat them, because otherwise, thanks to you, we have a lot of evidence showing that we shouldn't disturb them. So that's very important, the job you are doing.
I think for acute problems, it's more of a novel thing. You could probably customize that. You can make them accustomed to whatever you do. And if you're passing by with boats every day, sure, they get accustomed to it. They may get hit.
At some point,
they may
that's
get
what
hit
happened,
by the boat, or they may get deaf so they don't hear it, or there may be some other impact, and then you have long-term impact. So you may take away the acute impact, but then you have the long-term impact. And this is another thing why these places are so important to try to understand this. So another project that we work with you on is basically creating a Fitbit for marine mammals, or for dolphins and for killer whales. So we can put these instruments with suction cup. It's the size of your phone. It measures not the number of steps, but the number of tail beats, which then translates into number of calories, which then we can translate, they need this much fish.
Yeah.
Then we can look at the status of the animals in the wild and say they don't have enough fish, or they do have enough fish, and try to understand that a little bit more, and understanding the impact. We just completed a study that I think is being just sent out, where we looked at this in Sarasota in dolphins. What is the impact of boat traffic and boat approaches on dolphins? What is the metabolic impact? How many more fish do they need to eat when they're continuously disturbed? Surprisingly, there wasn't that much.
Okay.
But this is in Sarasota, where every day they have, I don't know how many, tens or hundreds of approaches of boats. So they may be accustomed to it. But that doesn't mean that it doesn't take away from, they may get hit by boats. They may be accustomed to it in a way that it is detrimental for them in the long term. So.
Yeah, and sometimes we forget that having all those boats every day, every month of the year, it's not the baseline.
No.
And we forget that they are not living in a baseline. The baseline was before the humans were there. So we have to be careful with that. Thank you so much for all this information. My last question will be about the future of your research. In which direction you think you will go, and what are the new projects? Because you never have enough. You want to know more.
No, but especially the heart and the lung, I find interesting.
This connection.
Yeah, so the connection between, because we think of the heart as one organ and the lungs as another organ, but it's sort of a married couple, because they're very, very interconnected. So every time you take a breath, you affect the heart rate. And I'm not sure if it's the other way around. So I think that the lungs is the female and the heart is the male, because one is affecting
the other. That's a nice way to put it.
But I think that we need to start thinking about it this way. And how did they join each other? We have a hypothesis that it works very, very differently in marine mammals, especially in cetaceans. So they have this very unusual lung that allows them to avoid, and we see a similar mechanism in turtles too. We proposed a similar mechanism in turtles. So they have this capacity of basically they can select, and this is a complicated thing to explain, but basically they can select which gas they want to exchange. So they can select to exchange oxygen and carbon dioxide, but not nitrogen.
Wow.
So they have a built-in titration system where they can avoid decompression sickness of taking up the nitrogen, but they can exchange some oxygen and CO2. When they dive too deep, no, then there's no gas exchange because the lungs are collapsed. But they can do this probably at 2-3 meters. So they can completely avoid taking up nitrogen. And then when they're stressed, this is what we think is happening to these animals that are being exposed to sonar that Antonio Fernandez and his group have been looking at. When they're stressed, this mechanism fails because it's a coupling between the heart and the lungs and how they're working together to make this possible.
And then you disrupt that.
Yeah, they're basically solved a physics problem without knowing it. And then it fails, and the mechanism basically fails because of stress, and then you're taking up too much nitrogen and you get bubbles.
That's very interesting. So I'm pretty sure you have a lot of research ahead for your career. And just to remind the people listening to us, everything is published. So when you do science, you said also repetition is very important of the measure. Then you submit the data, then you publish it. And I don't know how many publications you have, but a lot.
No, but I think it's important. One is not just getting it out there for the scientific community, but it's people's time. We come here and you have dedicated a lot of time. The animal is giving us their time. The park is giving access to these animals. So I feel an obligation that we need to do a study that is actually resolving one question. Yes. And a lot of them, not all of them, but a lot of them, for me, it's important that they have some conservation impact. No, it's not going to be, I solved the problem tomorrow, but it's a small piece of the puzzle.
Yes.
Of stepping forward.
Yeah.
And what you're doing now, I think, is crucially important, that we need to also not just publish this there may be 3 people reading my publication. Yeah. Mm-hmm. But we need to be able to translate this into, what does this mean to me? I'm at home and now I can't drive my boat as fast as I want to because someone has made a new law for these animals. But if we as scientists can tell the story, this is why we're trying to do this. I think that it's easier for lawmakers and for the public to buy into why some of these laws are existing.
And the zoo is a perfect place to explain to the people this connection that we have still with the nature and why we're responsible, and why these data translated in measures, as you said, is very important. So I think zoos, because we have a lot of visitors coming interested by the animals, that's a good place to explain all this story.
If you talk to probably 90% of everyone doing similar work that I do probably have a story about a zoo in their childhood.
Yes.
And I think it's the success of zoos of making that connection.
Exactly. And it is more and more important, I think, and it will be in the future. Thank you so much for having answered all these questions. It was very interesting. We could have keep on going for ages, but very, very thank you. And we are looking to continue the cooperation, new projects, and maybe you come back to explain about it.
I hope so.
Thank you so much. So that's the end of our podcast, Wild Voices. It was about marine mammals. Maybe next time you will have another one with Rafael Zamora on parrots, and then I will come back with other stories about marine mammals. Bye-bye.